We're going to take a look at the first two types of control charts for attribute type of data. So we are going to take a look at the P and NP charts. So first we're going to take a look at the NP chart. And it really is the number of non-conforming items. So we see over here the different types of reasons an item might not be conforming. So in our case, it could have a dent, scratch, nut missing, warp, bent, things like that. And we see counts. So for this given sample here, each column is a sample again. For this given column, 4 were dented, 3 were scratched, 2 were missing a nut, 1 was warped. So there was a total, if you add those up, there's a total of 10 non-conforming items. And the total inspected was 20. So this 10 here, total number that were non-conforming for this sampling period, sampling where we inspected 20 of them, 10 of them were bad for these reasons. That 10 is plotted here. So that's pretty straightforward. This tells you total inspected, and this tells you the number non-performing. So this number equals this number in all cases. Now, similar to the other control charts where we see the bar above the symbol, in this case NP bar, that is the average of non-conforming items. So if we total up this number in each sample for all samples, and then we divide it by the number of samples, that gives us our average. So every time we take and inspect 20 items, on average 4.9 of them are defective or non-conforming. So that's the average non-conforming items. So we can watch that average over time and see if it's increasing or decreasing and get an idea of whether we're seeing things change. Now, if we take a look at the P chart, which is extremely similar to the NP chart, there's one subtle difference. And the P, you can kind of remember it because it's percentage. Percentage of non-conforming items again. We see the same numbers here. So we have a column and we have the counts for each of our reasons, just like we saw in the NP chart. We see our total of 10. We see that we took a sample of 20, but instead we see a 50 here. And this is really a percentage of non-conforming items divided by inspected. So in this case, 10 were non-conforming, we inspected 20, it's 50%. And then we see down here, this plotted point is 50. Here we had 4 non-conforming, we inspected 20, that's 20%. So then you see 20 down here. So very similar to the NP chart, only we're dealing with percentage here. And likewise, we have our P bar, And that is totaling up the percentages of every sample, dividing by the number of samples, and we get the p-bar. So in this case, 24.4. So every time we take a sampling and inspected 20 of them, 24.4% of the units on average are non-conforming. So p-bar is our average of our p, which p is our percentage of non-conforming divided by our inspected, gives us our percentage. It works well if your total inspected varies. So here maybe we inspected 20, we inspected 10 here, 15 over here. Because we're dealing with a percentage, we can plot it out, and that's going to be consistent in the chart. If these numbers are always the same, then that's when the NP chart can be used, because we're always comparing it to the same number inspected. You're seeing that count, and you can look for changes of that count relative to the number inspected. So again, your NP chart is good for total inspected, always the same. And your P chart is good for when your total inspected varies.